Good afternoon, everyone. Pleased to present to you Josh Burkus, Postgres core team member and I guess all-round Postgres guy.
Okay.
And yeah, you're also involved in lots of other projects by the look of it. Sounds interesting. And look forward to hearing about Postgres 9.2.
Okay. Thank you very much. Howdy, everybody. Postgres 9.2 was released at this point about 4 months ago, and I'm really excited about it. We've been calling it sort of our race car release. Actually, we've been calling it our NASCAR release. Now, how many people here know what NASCAR is? It's an American thing, right? So we're told that, we call it this for a couple reasons. Number one, because it is absolutely the fastest Postgres yet. By a substantial margin. I'll be talking about that. The second reason is, just happens due to timing that when we did the announcement, I was in North Carolina, the home of NASCAR. Now, they tell us that NASCAR stands for North American Stock Car Racing Association. But those of us who've been to North Carolina know what it really stands for is, woo-wee, NASCAR! So, let's go see some nice cars. I'm going to take you around the racetrack here. We're going to start out talking about read scalability and then write performance, and go to index-only scans, cascading replication, JSON, through the dark and murky depths of SPGIST, into range types, DDL migrations, admin tools, wind up with a few other features, talk a little bit about what's going into 9.3, and then we'll finish up. I've got a lot of demos. I probably won't get through them all in the time available, but let's try. So, everybody ready to start your database engines? So start your engines. First, we're going to talk about read scalability. Lots of people out there are now using Postgres in devices where your database is smaller than memory, where you have lots and lots of cores. And we discovered that we weren't maximizing our use of hardware resources under the circumstances. Particularly, we got some really big, really fast machines from HP and the University of California to try stuff out on. So then various hackers, Robert Haas and Heike and Tom and this sort of thing, got together on this. They put through a whole bunch of different patches to make various operations faster and to make us do less locking, including lots of really cryptic calling things. My personal favorite was the patch called heaphot search buffer. But the result of all of this technical work is much, much faster stuff. So we're sort of detailed here. This is on a 64-way server at the University of California, Berkeley. 64-way server with, I think, half a terabyte of RAM, and a database that fits into RAM, and a read-only workload. But it's not all that uncommon now for web applications to look a lot like that. And so this little green line, that's 9.1. And this is 9.2, which continues to scale up to 64 clients symmetrically before it starts to level out, as you would expect in a 64-way server. Now, because you can't see the numbers from most of the room, that's for anybody who's missing that, 350,000 queries per second at peak load. Woo-wee! Nice car! So, but of course, if you were just doing reads, you wouldn't necessarily use Postgres. So we needed to make writes faster too. Now, I couldn't get quite the same amount of gain on writes that we got on reads, but we could do a lot of things to make writes faster. So, for example, Simon and Peter worked on better group commit. We worked on reducing contention over the lock to the transaction log. We worked on doing better copying of tuples in memory and that sort of thing, and reducing the amount of checkpoint activity. And again, the result of all of this work in 9.2 is much faster writes. So this was a graph done by Heike of various patches that we worked on for improving stuff. And this blue line is what we ended up with for 9.2. The red line is, again, 9.1 here. So you can see, again, on faster servers, this one, a 32-core machine, on faster servers, we can now get a much higher degree of concurrent writes. Actually, as much as 50% more writes per second in terms of throughputs for single row writes of databases. Now, people also tend to do a lot of bulk loading into Postgres. How many people here have bulk loading of large amounts of data as part of their regular routine? Yeah. So one of the limitations we had with bulk loading before was that if you tried to do more than 3 parallel bulk loads into a single table, it would just sort of lock up, and you wouldn't actually get more than 3 bulk loads full throughput. Well, we fixed that. And you can now get, if you've got really good I/O with multiple channels, you can take advantage of it, and you can actually parallelize your bulk load. Your bulk loading into a table. You divide up, say, your bulk load into 10 different chunks, bulk load them all in parallel, and load them 3 times as fast, so that you can do your bulk loading a lot faster. So, faster database. Don't have a demo for the faster stuff because I'm on my laptop. Wouldn't be that impressive. couldn't get the 32-way machine through customs, oddly enough. Still waiting. So, now, there is something I could demonstrate, though, which is something people have been waiting for in Postgres for a long time. It's a little bit of an embarrassment that other databases had this long before we did, but we finally actually got it implemented. And this is index-only scans. Now, let me explain why it was difficult for us to implement index-only scans in Postgres and why you want index-only scans. So, the way that, this is a sort of symbolic thing of like, your basic B tree index, right? So we got the index here, and you're asking for some bit, and you're actually looking up stuff here. This is the table, or known as the heap, right? In Postgres, the index and the table are completely separate, and the table is not necessarily sorted in any way. And what would happen when you looked up an index, if you were looking up something that corresponded exactly to the conditions of the index, to values, for example, that were being stored in the index, like you just wanted the name of the book, that would be very fast. But looking it up in the heap would not necessarily be that fast. So why do we have to actually check the heap? Well, one of the problems we have in Postgres is it's a highly concurrent write system. So what can happen is while you're doing your index lookup, somebody could delete a couple of these. And then we actually need to know, can you still see those, or were they deleted before you started your search? And in Postgres, that information is only contained in the heap. And the problem with that is that looking up the value in the index could be quite fast in a lot of cases, whereas checking the heap for visibility information could be quite slow, as in much slower than looking up the value in the index. So I want to come up with a way to look up the value in the index only. This is, by the way, the count star is slow in Postgres problem, for any of you not familiar with that. So we wanted to make it possible to look it up only in the index, at least under good circumstances. So what Heike did was, we'd still look up the thing in the index, but now instead of checking the heap, we have a bitmap, which is usually cached in memory, unless you've been running out of RAM because of too much activity. It's usually cached in memory, called the visibility map, that simply keeps track of what data is visible to all users. And so whenever you're looking up any data that is now visible to all users, you will be able to simply check the visibility map instead of checking the heap. And that speeds things up considerably. Oop. What on earth? Hold on. I didn't actually. That's very interesting. Yeah. Sorry, I'm going to have to jump out of the presentation. That's kind of irritating, but no. OK. This works very differently when I'm connected to a monitor. Sorry. Come on. Give me a title here. No. There we go. OK. So this is 9.2. Now, index-only scan happens automatically. So to show you how it is the old way, I'm going to turn it off temporarily. And then, so let's see what happens when you actually do like a count star, right? So I'm going to do account start from PG bench accounts. This is explain analyze, which tells you how things were actually executed. And takes a little while. And you see that we do, so up here, this is the important part, sequential scan. So it's actually doing a full heap scan to actually check that count. Now, we're going to go ahead and turn index only scan back on. And we're going to do that same. And now we're doing an index only scan on the index, which, because it's smaller than the table, takes about 40% of the time that the last one did. Now, in this particular case, both the table and the index fit in memory. In cases where the table doesn't fit in memory and the index does, the difference can be a lot greater than that. And not only that, this isn't limited to things like count star. It's limited to anything where you can actually get all of the data from the index. So I actually have an index here on BID. Well, actually, let me show you the index that got. So I've actually got an index here on BID A balance, which means that I can actually do an aggregate on that and still do an index only scan. And that runs at about half the time that it would take without the index only scan. And again, the bigger the table is, the better the advantage is going to actually be from the index only scan. And that is complete fail. Yeah, there's a couple, well actually mostly there's some limitations, which is that we're checking this visibility map here. So if you have a lot of dirty blocks in the table, things that were recently modified and might not be visible to all transactions, then Postgres will automatically drop out of the index only scan and use a regular scan. It also has an in-between mode where it index only scans most of what you want and then checks some of the heap blocks but not all of them. So it's never a negative when it's being used. We did a lot of testing the cost model of this, and we seem to have gotten that right. At least we haven't had reports that it's doing it at the wrong time. It just can't always use it. So more features, we don't have a lot of time. Cascading replication. How many people here are using Postgres binary replication? A few of them. So 9.0, we added binary replication. And in 9.0 and 9.1, binary replication has this limitation, which is that all replicas have to replicate directly from the master. As in, they're all going to have a connection, a port connection to the master for replication. Which is fine. Lots of people have done lots of things with binary replication. It's very high performance, very reliable, very useful, that sort of thing. But sometimes you don't want to replicate directly from the master. Sometimes you want to do something where you are replicating to a replica, and then that replica is replicating to other replicas. Well, why would you want to do that? Well, imagine, for example, that the master's in Sydney, and these replicas are in North Carolina. Well, in that case, this link here is costing you a lot of money per megabyte. So you don't want to be sending 3 replication streams over that link if you don't have to. There's also other reasons for failover configurations and stuff why you want to use cascading replication. But it is a great useful feature that allows people to scale up their replication infrastructures a lot more. So let's go to, it's also really easy to set up. Can I actually, no. No, I can't. Okay. There you go. So first let's set up cascading replication. So what we've got right here, right now, is we have a master server. We have a replica server. This is all running on my laptop. It's just separate Postgres servers. I do this demo in the cloud sometimes, but I figured depending on the conference, wireless might be unwise. Let's go ahead and, okay, so I'm going to do this command, which is pg-base backup. Sorry about the wraparound, but pg-base backup is the simple way to create a new replica, which you just say pg-base backup, you say copy the transaction logs, this is just V so we can see what it's doing, what database directory we're using, and where to connect to. And in this case, 5493, I'm actually connecting to the replica and not to the original master, because the master's running on 5492, replica's running on 5493. So I'm just going to go ahead and connect to that. And it's going to spend a couple of minutes copying files. There we go. Oh, right. First, I need to do a couple things. One is, because I'm running this all on my laptop, I need to change the port number. And so this is recovery.conf. For those of you who have not done Postgres binary replication before, recovery.conf is the oddly named replication configuration file, which is separate from postgres.conf, right now anyway. And we need to tell it where to connect to. So right now, this is the replication configuration file which was copied from the first level replica. So I'm going to tell it to actually not connect to the master, but to connect to the second level replica. And all I have to do is change the connection info. Now we're going to go ahead and start up. So if we actually look at the master now, let's stretch this out here. So if we look at pgstat replication, this is the original master. It has one replica. And then this is the replica master here, which has its own replica. So that's setting up cascading replication. So you can now go wild with it. I'll warn you, don't use cascading replication if you don't have a good reason to. It does make your life more complicated, but lots of people have good reasons to. There's also a bunch of other replication improvements. There's a replication stream reader that reads out replication writes files. There's standby only backup. There's receive versus write modes for synchronous replication. Anybody using synchronous replication? Yeah. The idea of synchronous replication, now you can actually set the degree for how synchronous it has to be, which means you can sort of trade off data protection against speed. Lots of other useful stuff, making replication more useful. Now, the other thing that people have been really excited about, that lots of people came up to me when 9.2 was being released to talk about, oh, I'm so glad you added that, is JSON support. How many people here program in JSON? Yeah, see? Not program in JSON, program with JSON as data. Nobody programs in JSON, at least I hope not. So you can do all kinds of things. So we had, better to just demonstrate this. Let's bring up my JSON window. There we go. So, one of the first things that we can actually do here is, so we're going to show, so we have this books table, which is wrapping around way too much, so I'm not going to show it you that way. There we go, we've got sort of a books table, it's a little, just having information about publication of various books. Optimistically, we have ISBN as the primary key. And I say, okay, well, this is all nice, but my application is written entirely in JavaScript. And so when I send a query to the database, I'd really like to get it back as JSON. Is there a way to do that? Well, now there is. Row to JSON. So in this case, this new built-in function with row to JSON will actually output the result from the books table as a very simple JSON format, so that it can be used directly in languages that have lots of tools to manipulate JSON, rather than needing to read it out in column format in the language and convert it to JSON on the client. So that's pretty nice. And it's generally useful. You can see a lot of things that you can do with that. There's also what?
Please.
Yeah.
Thank you.
There you go. Select row to JSON. There's also an array to JSON function to directly convert Postgres arrays to JSON, and you can nest these things. So if you had a table with arrays in it, you'd get rows as JSON and then JSON arrays within the JSON. Works great. We're already using it in production at one of our clients, actually. But the other thing is, we don't want to just have conversion functions. We want to have ways to store JSON. So imagine that I live in a wonderful fantasy world. Here, anybody here work in like publishing or library applications? Like public library book lending? No. There we go. Imagine I live in a fantasy world where the library system is sensible enough to use a standard format like JSON for records. You really don't want to see the format they do use. Anyway, and I was receiving those as updates from the upstream from the parent library or whatever. I might want to store them as JSON. And I can do that. We now have a JSON data type in Postgres. And we got this JSON data type. And if you actually do you can actually look at this, and it's again the same, in this case, simplified JSON, but you can, any sort of arbitrary JSON that you want to stick in that field will be in there. Postgres validates to make sure that it's actually correctly formatted, at least in terms of brackets and quotes. Now, that's sort of useful, but to make it really useful, just like for a race car to be really useful, you need an engine. For the JSON data type to be really useful, we need an engine. And that engine's called PLV8. Anybody familiar with Google's V8 JSON engine? A couple of people. So Google released this open source thing. It's part of Chrome, which is their whole JavaScript engine, the V8 JavaScript engine, that does just-in-time compiling of JavaScript. It executes it really, really fast. And it's a really nice thing. And because in Postgres, you can plug in anything you want to as a procedural language, a Japanese programmer went ahead and wrote a plugin for V8 and Postgres, PLV8. And it turns out if you combine PLV8 and PostgreSQL, you can get really fast executing JavaScript in PostgreSQL to manipulate all that JSON that you're storing in Postgres. So, I'll demonstrate things. Obviously, now you can always do the dumb things. Everybody does a Fibonacci sequence right now as a demonstration of a new language. But let's do something a little bit more relevant for the database. So the first thing that we're going to actually do here is I'm going to create a function. And I actually created this earlier, so I'll just show it to you right now. And this is called JSON val, and it actually just it created this JavaScript function, and it just basically extracts a particular key from a flat JSON. I'm already making the assumption that this is flat and not a nested structure. And just returns that key, and it's actually quite simple. But, oops. So once I've created that, and if I create it as an immutable function, the really nice thing I can do is that I can now create an index on it. So I can have an arbitrary index on a particular value in my JSON. And then once I actually have that arbitrary index, Postgres will use it. So we got our index scan on the arbitrary index in JSON val. And so you can create sort of CouchDB style ad hoc indexes on particular JSON extractions using PLV8 and Postgres' new JSON type. Anybody here use CoffeeScript? Because once we had JavaScript support, it was easy enough to add CoffeeScript support. I don't use CoffeeScript myself, so I'm not going to demo it, but it's there. Now, indexing. One of the big things that we do in the Postgres project is advanced indexing, all kinds of complicated, sophisticated advanced indexes. So in version 7.1, we got the generalized search tree, which has now been used for all kinds of things, for spatial searches and tree searches and all kinds of other things. In 8.1, we got the generalized inverted index, which is now used for full text search and array search and a bunch of other stuff. In 9.1, we got k-nearest neighbor, which is proximity search for spatial searches. So you would assume that it would be 10.1 before we'd get another new special type of index. But no, in 9.2, we've got space gist. So this is based on a theory called space partitioning trees, one of the first databases to implement this. And it uses a lot of the same sort of tree structures that gist indexing does. I'm not an advanced index guru, so. But in cases where you have a lot of similar data, You can do things like quad trees, which are very good for geographic information, or you can do things like append trees, which are very good for things like URLs, where the beginning of each value tends to be the same. You end up with indexes about the same size as gist that you can use for a lot of the same purposes, but that load faster and search faster. This was an example that Theodore, who's one of our index gurus, did from PGCon, where he showed loading the same geographic index. So you see that it loads in 1/3 of the time in the new space gist. I don't have the search example, but it loads in 1/3 of the time. It actually searches in about half the time. So faster, complex indexes for complex data. More features, range types. Now this is the one that I'm really excited about because I programmed lots of calendaring applications. Anybody here done a calendaring application? Don't you love doing where this is greater than that, or that is greater than the other thing, or these are between the two? Isn't that lots of fun? Yeah, well, getting rid of that. Now with range types, the idea of range types is anything you can represent as a linear range of discrete values, or of continuous values, can be represented as a range. And these are mathematical ranges, so we've got open intervals and closed intervals. Now, the biggest use for this is for timestamps, to do calendaring and that sort of thing. We can also do alphabetically, you can do linear distance, all kinds of other things. And so this is the one that I'm really sort of excited about. So let's actually do range types here. So, so we've got a copy history table here. And once I scroll too far. So we've got, okay, well, can't really say this is our period column. Actually, what I'll do here is do that again. Now you can actually see, okay, here's the table. So we got the book copy, what its status was, and what period it was somewhere. And if you do, you can see stuff like this, right? You know, it was in transit, and then here's the period, during the period where it was in transit. And it's a closed open interval, meaning it started at this moment, stopped right before that moment. Now, where this actually becomes useful is if you want to have a query like, ooh, and that's going to be hard to see. Okay, hold on. So if I wanted to say, hey, I want to see every book that was loaned out during any portion of May 2001. And so what this gives me is where the period overlaps at, well, where the period is contained, sorry, any book that was loaned out within May of 2001. So this period gives me where the period is within this time range of May 2001. And so then we get a whole series of books that were loaned out during that period. Or I can do the same thing and I can say, hey, I just don't want to see ones that were loaned out completely within that period. I want to see ones that overlapped, were loaned during any portion of May 2001. If they returned 20 minutes into May 2011, I still want to see them. And then that gives us that, where they were loaned out for any portion of that period. These are Postgres custom operators. You get used to the sort of overlaps operators and that sort of thing. Now, one of the other things I can do is I can actually try to do data integrity here. So what I'm doing here for data integrity is I want to say, I want to make sure that in this history track, I don't have a record of a book being in two different places at the same time. So I say, the copy ID, I am going to make sure, this is called an exclusion constraint, which we introduced in 9.1, was not as useful without range types. Now we have range types. Exclude using just, with equals, period with overlaps. And when I do that, actually, I find out my data's not clean, because I'm getting a uniqueness violation. Which means that I actually have recorded the same book being in two places at the same time. If I'd had that constraint in the first place, that wouldn't have happened. So, and we are going to, that's going to be all for the demos for now, because I'm almost running low on time here. Now, well, actually it won't be all for the demos. One more demo. So, one of the things that any race car driver can tell you is that you win not so much based on how fast you drive, but on how little time you spend in the pit stop. Just like it's more important that your application not be down than how fast it is. So when we are doing database schema updates, when you're doing code pushes to our database, we want to spend as little downtime as possible, preferably none. And 9.2 improves the situation in that regard even further. Postgres is pretty good about that. 9.2 makes it even better. We've added drop index concurrently, so you can now drop an index and have it just opportunistically wait for the locks in the table to disappear without blocking other writes while it's waiting, which is important. Not valid check constraints, so you can add a new constraint. And again, wait to validate it until you have a low period. Less rewriting for alter table in a bunch of circumstances, alter if exist for a bunch of other objects, making your idempotent scripts a lot easier, rename domains, foreign data wrappers, vacuum skipping pages, data pages that are locked, all kinds of things to make your background activity happen without interfering with the application. Now, the other really important thing when you are using a high-performance instrument like Postgres is to have really good instrumentation so you can see what's going on with Postgres. So we added a bunch of new instrumentation to 9.2. The biggest one, which I'll show you in a minute, is more pgstat statements. We've actually taken pgstat statements, which was an optional tool from a while ago, and Peter Jurgen overhauled it to make it much more useful. More auto-vacuum logging, ability to view and track I/O and that sort of thing, deadlock, temp file counters, etc., checkpoint timing. So, last demo. Okay. That's probably this. pgstat statement. So, here I am in database that's been running a benchmark and that sort of thing. So I want to see what it was running the benchmark and how long it took for various things. Actually, let's make this a little bit smaller. Oops, I don't have pgstat statements installed. Wow. You guys know about extensions, right? If I already have the binary file installed, which I do, which I built it with Postgres, the binary file installed in Postgres' shared directory, then that's all I need to do in order to install pgstat statements. And now I've actually got, oops, let's go. So we now look at what we spent our time on. Actually, that's not very interesting. Let's sort it by time here. So we did this update statement, did it 246,000 times. The total time required was 277,000 milliseconds. This is how many rows we hit. And if you've got the track I/O stuff turned on, which is an option in PostgreSQL.conf, you can also get information about what sort of I/O we did in order to hit those on average, right? So how many blocks did I hit in the buffer versus how many did I actually have to read from somewhere else? Now, this database was largely buffered, so we hit almost everything in the buffer. Same thing here. We're hitting all buffered stuff. So that would be very good performance in a production database. In this case, it just represents that I'm benchmarking on a very small database. So lots more rich information. pgstat statements, you'll want to turn it on in your production database. For anybody who's using Heroku, it's turned on automatically there. And in a lot of cases, it can spare you from parsing the Postgres logs to look at your query performance, which is a wonderful thing. That's configurable. Default is 1,000, but you can configure it. So let's finish up. Better explain. I'm not going to give you a demo of this because, well, no, actually, I have enough time here. Better explain. So there's a couple of new features for explain. No, except I have to turn X off. A couple new features for explain. Such as with the new I/O tracking, I can actually see what sort of I/O I did for a particular query. So in this particular case, I did a select star from pgbench accounts. And so this is going to do a sequential scan of pgbench accounts. Now, what this is telling me, shared red here, is that the entirety of that table is currently in the buffer cache. And so it's just going to read out of the buffer cache. But you'll also see logical reads here from the file system cache to the file system. That'll give you an idea of when you have slow performing queries, is it slow because it's doing a lot of I/O? There's a couple more features for explain analyze. You can look at them later, but to give you these sorts of things. Also, for anybody who's got, does anybody here have to run Postgres in Windows? Okay, so you're lucky. The no timing option is mainly for the Windows users because the system clock in Windows is completely shot. And as a result, if you are trying to look at query timings, the explain analyze takes forever. So the no timing option is for those poor people. The other features. Put in some power savings for everybody running Postgres and virtualization and that sort of thing. We eliminated a lot of unnecessary CPU wake-ups. Lots more stuff with SE PostgreSQL, SE Linux integration in order to some optimizer improvements, some fixes for PGHP.conf XML improvements, exportable snapshots, which is only important to developers, but it's pretty cool. And more PG dump, PG restore options to dump certain specific things, breakout stuff. More PSQL features because all of us hackers use PSQL, so we keep adding stuff to it. PG upgrade fixes. Oh, we dropped support for a bunch of antique platforms. So is anybody here still using Postgres and BSDI? Solaris 4?
What?
Okay, good. You know, if you were the one Ultrix user out there on Postgres, I'm afraid you're screwed now. But the
My data general?
yeah. Well, actually, the reason we dropped BSDI was that Bruce's BSDI machine finally died. And we're done with 9.2. We released in September. We were very excited about it. We got lots of news coverage, and people are very excited to be using 9.2. But of course, I'm a Postgres developer, which means I'm already thinking about 9.3. As a matter of fact, 9.3 is getting a couple of weeks away before closing the tree and going into beta right now. So what's coming in 9.3? More JSON goodness, accessor methods, the stuff that I showed you with PLV8 actually won't be 100% necessary because it'll be built in C code and Postgres for accessing individual JSON items, etc. Writable foreign data wrappers. Right now, foreign data wrappers for accessing external data are read-only. They'll be writable in 9.3. Event triggers, which is basically write a trigger on anything. Like when this user logs in, fire this event type thing. Updatable views, create your own background workers. You want a task manager to run as part of Postgres. Lateral joins for the serious SQL geeks. Anybody even know what lateral is? See, it's a way to mess with your head, really. I'm not going to have a demo right now. I'm a SQL geek, and it messes with my head. But it is really useful, particularly when you have row set returning functions. Streaming only remastering. Right now, you need to do file copying if you want to remaster from a replica. And you want to do that in the future. Improve foreign key locking. PGStat plans, which is a complement to PGStat statements that logs your various explain plans. So that you can, if a common query suddenly got slower, you can see when the plan changed. And the biggest thing of all, how many people like setting this in syscontrol? Yeah. We won't have to set it anymore. We're M-mapping most of our memory at this point and only using System 5 memory for a small amount of what Postgres needs, and what we need now fits within the defaults of every operating system. So no more having to set that, thank goodness. So that's all. If we have a little bit of time for questions, we've got 4 minutes for questions, I think. And before we go that, for other information, we have some stuff coming up. Anybody who's from Melbourne and can convince their boss to give you yet another day off, we are doing a full Postgres day on Monday.
I think it's full.
Is it full?
I tried to register, it was full.
Damn. Okay, well, I've been very good at selling it. But email me later, because I'll check and make sure that it's really full.
I didn't check with the boss because it was full.
Okay. Well, if there's still time. I will have a PG day. If anybody's going to PyCon, we'll have a PG day at PyCon. And there's PGCon in Ottawa, which is our annual developer conference. So, questions?
Sorry. Yeah, congratulations, fantastic,
Thanks.
Brilliant. And we're big users and we love it. My question is, we also use PostGIS. Any idea whether they're going to take advantage of some of these?
They're working on incorporating particularly SpaceGist. obviously. They're working on incorporating that into the next version of PostGIS. So expect 2.1 whenever it comes out to have SpaceGIS support.
Thanks.
Just a question about replication. Are there better stats available in 9.2 than, say, 9.1?
Yeah, if you actually look at, let's go back to our replication demo here. Nope, not that one. There we go. So if you actually look at this, one of the things that we've added is some additional information and feedback about where the replica status is. Now, I'm not running a workload now, so they're all the same. But these are file locations for what the status of the replication is in terms of data. And we added this function called pgstat, hold on, except I got the name of the function wrong. So pg xlog location diff. And so that will allow you to actually compare those mathematically in terms of bytes, how many bytes apart are the two different servers, so you can tell when you're lagging behind. We also added for the replicas a function to determine the last commit timestamp that the replica's seen. Now that's not the last data that it's seen, it's the last time it saw a commit message or a rollback message. But that can still give you an idea in timestamp form how far behind, or not behind the replica is. Other questions?
Materialized view support, any thoughts on timing, or it's been discussed for a while? So.
Kevin Grittner's been working on materialized view support. And right now the patch doesn't look very good for 9.3. There's still too many major issues with it. So 9.4 is looking a lot more likely. Not that if you're in a position to help with code, with reviewing and with testing and stuff, there's still a couple weeks of time to actually get involved in that and maybe turn it around. But you want to actually go home and do that tomorrow. There's not that much time left. Other questions?
Does the range type allow you to do comparisons with how if there's been any books loaned out for more than 2 weeks?
Yeah. Well, what you do in that case is, the question was, does the range type allow you to do comparisons if, say, there's books been logged out for more than 2 weeks? What you do is, there's built-in functions to extract the start point and the end point of the range. So you just extract the start point, compare it with now, and see how long it's been. Range types also support, for data types that support infinity, such as timestamps and numerics, range types also support infinity as endpoints. So for example, if a book has been loaned out and it hasn't been returned yet, then you have the range type of yesterday infinity to show that you don't know when it's going to be returned. Nulls are actually compared on the same basis. Nulls are treated as infinity in range types, which can confuse some people at first, but it was the only thing that seemed to make sense. I think, are we out of time?
2 more minutes.
2 more minutes. So another question. All the way in the back there.
G'day. Can you include non-indexed columns in an index so you don't have to go to the heap?
No, you'd have to index them. I mean, Postgres supports any kind of multi-column index, but you're going to have to index the columns or they're not in the index.
Yeah, just some other databases allow you to include them, but without the expense of the index.
Just for coverage.
Yeah.
I'm talking about the query, just for coverage.
So like you're doing a sequential scan on the index, just if it's
I don't know. In that case, you would just have another heap. I don't know how that would work exactly.
Yeah.
I think that makes more sense with databases where the heap is not separate from the primary key index. In the case of Postgres, they're separate. So that makes a lot less sense. If something's not in the index, it's not in the index.
Isn't he talking about a conditional index scan, which you already do now?
Yeah, well, we can do partial indexes. So, I don't know, I'd have to see an example of that.
Well, just standard, if you've got 100 columns in your table and you've got an index that covers 3, but you know most of your queries are only going to want 4 columns, 3 of which are in the index, like, I
Yeah.
SQL Server.
Yeah, no, then you have to go to the, then you have to go to the heap, or you have to include the 4th column in the index.
Yeah.
So, okay, one more question? Do we have one more? Yeah.
Okay, last one.
Yep.
The efficiency of the foreign data wrappers. Like if you were doing index and search of whole file systems, and instead of actually having the file system generate the index and chuff it into Postgres, you wanted to turn that around and have basically the file system exposed as a foreign data wrapper, and then use SQL to index it. Would you think about going the second way, as far as efficiency goes?
Yeah, so right now with foreign data wrappers, right now with foreign data wrappers, though, Postgres has to read the external data source into Postgres before it can do anything with it. So it depends on how large the external data source is likely to be. If it's a file system tree, then certainly, because reading it in doesn't take that long. If it's, well, unless it's a file system tree on a giant storage device that has 800 million files in it. Yeah. Now, one of the things that might or might not make it into 9.3 is what's known as pushdown, where if your foreign data wrapper has been defined with a way to filter information on the remote side, then when you put a where condition in your query, it'll actually push that where condition down into a filter on the remote side. Obviously, that's a much easier thing to develop if the foreign server is another SQL database of some kind, as opposed to a file system. But there's nothing theoretically preventing a creative foreign data wrapper writer from implementing that pushdown even for, say, file system search.
Okay, thank you, Josh. That was fantastic.
Okay.
Congratulations again, and here's
Thank you.
a gift from us.